Yes, so students, how are you? We are going to start. We are going to start shadow pricing and Slack. Shadow pricing and Slack. What is shadow pricing and Slack? We are done with several limiting factor concept under linear programming when we have completed this graph using the calculations, making the equations, drawing the ISO contribution line, and using it to calculate optimum production point. We have taken both of the equations and calculated both of the units to calculate the optimum units, and then we've calculated maximum contribution in the last class. Then I give you the assignment which you are supposed to submit to me before going to the next lecture. So first of all, we'll discuss these assumptions at last. First of all, we are going to start shadow pricing and Slack. So what is shadow pricing and Slack? First, we'll discuss this Slack. See, the story behind that is we have made the graph. This one, I've just pasted it, the graph we have made in the last class. Actually, this graph we have used to calculate optimum point, and I am mentioning that optimum point, that is this one. The point is this one. That's the best point, the optimum point we have calculated because it was far away. It was far away from that ISO contribution line. That was the concept. If you remember, that was the concept. It was far away from ISO contribution line, so that's why it was optimum point. If you remember, we have made four equations for the constants. Let me show you in the last class where we have made that these equations, these formulate constant I've taken down. I've written here. So these are the four constants. These are the four constants that was in the question. Now, if you see at the optimum point, we have only two equations. At the optimum point, we have two equations. First equation was this one, y is equal to 600. At the optimum point, I am telling the at the optimum point, the two lines that are intersecting, one line was for demand, that y is equal to 600. This was the optimum, the line on the optimum point. And other line, if you see, it was the line of A. It was the line of A. This line of A. A means department A. 8x plus 10y is equal to 11,000 hours. So these two were the lines that were intersecting on optimum point. What it means that department A and department C, and the demand Y, these both are the resources that are fully utilized. That are fully utilized means 11,000 hours of department A and 600 units of product Y. These are fully utilized. Obviously, we are having more hours in department B and department C. Like if you see the C line, if you see this line is after that optimum point. Again, let me show you clearly. This is C line, right? See, this C line is after optimum point, and same for the B. If you see this B point, this B line is also after optimum point. It means that the department B and department C has more hours, but we are not able to consume them due to the limiting factor, and the resources that are completely utilized are only department A, 11,000 hours, and Y is equal to 600 units. Only that two resources are fully utilized. Means we have just utilize department A and demand fully, but for department B and department C, we will say that these resources are not fully utilized, or we can say it is underutilized. Underutilized. We have not utilized it completely due to A and Y. Due to A and Y, we have not completely utilized these two resources, these two departments. We have utilized, like for example, in B, maybe we have utilized 8,000 hours, 8,500 hours. We have not completely utilized 9,000 hours. And same for department C, it has total 12,000 hours, but we are not able to utilize completely. So if I write here, fully utilized department are department A, and in product Y demand, and underutilized are B and C. Now, the departments that are underutilized, we will say that the slack is in this department. So slack means the underutilization of resources in any constant. Underutilization in resources of any constraint. So actually, slack is the difference between the used resource and available resource. For example, 9,000 are total hours. 9,000 are the total hours department B is having. And for example, we have used just 8,500 hours out of 9,000. So we'll say that 500 is the slack. So that's why I've written that that's the underutilization, means the difference 500 underutilization in resources in any of the constraints. If I ask you that whether in department A and Y is there any slack, you will say no, because these are the departments which resources are completely used. For B and C, you can say that there is slack because they are underutilized. So always remember, slack is only for the constraints which are underutilized. For the fully utilized resources, we'll say there is no slack. Now there is one more point here. One more point here. Obviously, these all are constraints. But we come to know that two constraints were fully utilized, two constraints were not fully utilized, underutilized. So fully utilized resources will be known as critical constraint. Critical constraint means that we don't have any more unit for them, means we have completely utilized them. For example, department A 11,000 hours completely fully utilized, so it will be critical constraints, mean if we want 1 hour more from department A, we are not having that because B and C are not fully utilized. 500 is the slack in this example I've written. So if in any case we want to use 1 more hour of department B, we can use because there is 500 slack, means underutilization. So it means it's not critical constant. Critical constant are always that resources, that constants that are fully utilized, and underutilized resources we will call them non-critical constants. I'm not saying that only the constants are that which are fully utilized. I'm not saying that constants can be fully utilized or underutilized. Fully utilized constant will be known as critical constants, and underutilized constants will be known as non-critical constants. If I ask you one thing, if I ask you one thing, that for critical constant or non-critical constant, slack will arise in which of the both? So obviously you will say that slack will always be in non-critical constant. Slack will always be in the resources which is underutilized, means non-critical constant. If any in any theoretical question it's written that critical constraint constraints have slack, so you will say false. You will say false because critical constants are completely utilized. There is no underutilizations, mean it has no slack. Slack is always with the non-critical constant. It was the concept of slack. So let me write the example here. The constraint that is not used completely, the difference between available and required resource will known as slack, so slack will be the difference between complete available resource minus the required resource if it is underutilized. In case if it's completely utilized, obviously there will be no slack. Slack will be zero in that scenario. Now there is another topic, that is shadow price. Slack just he will ask you theoretically, like sometime theoretically, sometime he can ask you numerically that what is a slack. So in numerical term, how will calculate it? Obviously, it will be in the questions. Now we have to see shadow price concept. Shadow price, because the topic was shadow pricing and slack in the book. So what is shadow price? Now you have to see this. See, we have discussed now that one constant is non-critical. It is clear that non-critical constant means that it is underutilized. Okay. It also means that if we want to arrange an some extra resource for these non-critical constant, we are having that. We are already having that. We can arrange it. Like for example, Slack is 500, means underutilization is of 500 hours. So if we want 10 hours, 20 hours more from that resource, we can use that. So that's why we'll say that we are having that, no issue. If we want, in any case, we want more hours, we can take from this non-critical constant. But in the scenario, if the constraints are critical, it means the resources are fully utilized. Obviously, the resources are fully utilized. Now I say you that if we want one more unit, means for example, you are having in department A, you are having 11,000 hours, and you have completely utilized that. Now you are having remaining 0 hours in department A because you have completely utilized that. Now I ask you to arrange 1 hour extra. So obviously you will have to see in the market, you will hire the labor for that to arrange that 1 hour. So what is shadow price? If, see, relate this critical constant concept to shadow price. If there is increase of 1 unit in critical constant, means 1 unit being 1 hour or 1 unit depends upon the resources. So if there is increase of 1 unit in critical constant, how much contribution will be increased? How much contribution will be increased? Means if you increase 1 unit of critical constant, 1 unit means if you are having 11,000 hours, if you arrange 1 hour, now it will be 11,001 hour, right? 11,001 hours. Now arranging that 1 hour, increase in that 1 unit will give you how much contribution. That's the shadow price. So shadow price is actually the increase in contribution. I have written here, it is actually the increase in contribution due to increase in 1 unit of critical constant. If anybody asks that if we increase 1 unit of non-critical constant, what will be its shadow price, we'll say that for non-critical constant there is no shadow price, because for non-critical constant we are already having resources, we are just not using them because of critical constants. But we are having the slack, we are having some resources that are underutilized. So in that case there will be no shadow price. This means in this concept, if you see, critical constants have shadow price because they're critical constant. If we have to arrange that, so increase in contribution due to increase in 1 unit of critical constant, it means shadow price will always be for critical constant, and non-critical constant have slack. So just use this concept while doing the theoretical MCQs. Critical constants have shadow price, non-critical constants have slack. Just remember it always. Critical constants have shadow price, non-critical constant have slack. Simple. So critical constant have a shadow price, and shadow price is the increase in contribution. Let us do the question here. Let us do the question here. I will do complete question. I will perform complete question and we'll calculate shadow price. Like it's written. It's written in Hebrews. Basically, there was a question in the book. The optimal solution was determined to be x is equal to 4 and y is equal to 4. Basically, they have calculated the number of units that x will be made 4 and y will be made 4. Number of units that will be made for both will be 4. Giving an optimal contribution of 360 means they are on this, when x is 4 and y is 4, you are earning the contribution, already you are earning the contribution of 360. The solution was at intersection of these lines. Basically they have given you also given you the points of the equations of intersection. Equations of intersection means the equations that was raised due to the optimal point. So these two equations were used to calculate these values, x is equal to 4 and y is equal to 4. So there are two departments, cutting department and assembly department. It means these both are critical constant. Sometimes students ask me that why these are critical constant, why, how we come to know that these are critical constant. Obviously it's written optimal contribution, and always the optimal contribution is calculated by using the equation that are critical constant. If I show you this graph, so we are using here this optimum point, right? So optimum contribution will be calculated at this point, and from this point, the two lines that are intersecting, they are actually critical constants. Like here, department A and Y, demand of Y, they are critical constant, and this point obviously will be critical constant. That will be in the question if we see, in this question if we see. So this means that cutting and assembly, this answer, optimal solution, optimal contribution is calculated on this line, means these are critical constant. Actually these are not underutilized, they are completely utilized. Now suppose, see, this is the requirement that you will be seeing in the question, in the MCQ, in the practice. Suppose one extra hour was available for cutting process. Now you have two equations, cutting and assembly. He is saying you in the question, suppose one extra hour was available for cutting process. Means he's saying that if it's 36 hours available here, if it's 1 hour extra available, calculate the shadow price for this additional hour of cutting time. Calculate the shadow price means calculate the contribution due to this extra 1 hour. And he will mention you in the question that shadow price will should be calculated for which resource. Cutting, maybe he can ask you for assembly as well. So for cutting I will do, but for assembly process I will ask you to calculate shadow price, then you will calculate. Now what you have to do, simple, what you have to do is 6x plus 3y is equal to 36 as per normal equation. 4x plus 8y is 48. 8y is 48 as per normal equation. But now you have to calculate what? Shadow price. And for shadow price, you have to increase 1 unit. And shadow price of which process? Cutting process. For cutting process, the hours available according to equation 1 was 36. You have to increase it by 1 hour, means you will write here 37 in the solution. The normal equation, it's given. You will take the equation for which you have to calculate the shadow price, just increase its resource by 1 unit. If it's 36, just do it 37. Now calculate the final answer to finally calculate x and y units, and then calculate the contribution. Then we will see the increase in contribution. Old contribution was 360. When according to this equation, old contribution was 360. Now you will calculate the after giving it one more unit, you will calculate the increase in contribution. How? Again, now it's simultaneous equation. We have done in the last class. If there is any simultaneous equation, we have how you have to do the question. So 6x plus 3y is 37, 4x plus 8y is 48. If you see it's 6x, and if you see it's 4x, we have to make both of the equations, any one variable we have to make same, the constant of which we have to make same. Like if it's 6, we'll try to make it 6. Or how you can make it, just I'm giving you the example. If you want to make both of the equations same for x, like value of x should be same, if you want to make the value of x same, what you can do, there are two ways. One way is take the bigger value from both of the equation, that is with x. So the first equation is having 6, second equation is having 4. What you can do this, like 6 divided by 4. Take this 6, divide it by 4. So it will be 1.5. It means that if this 4 is multiplied with 1.5, if this 4 is multiplied by with 1.5, you will get answer 6, right? So you can do like this, like, but always take the higher value upward and lower value downward. So just multiply this 1.5 with complete equation. Now equation will be 4x into 1.5, 6x, plus 8y into 1.5, 12y, is equal to 48, plus 1.5, it will be 72. It will be 72. One way is this. Another way I'll tell you after, when we'll calculate x and y. Now you go two equations. One is this, and second we have like calculated, so that you can calculate the number of units. Now what you will do, subtract equation 2 from equation 1. Subtract equation 2 from equation 1. I'll take these equation 1 and equation 2 downward. This is equation 1 and this is equation 2. Wait, I'm taking this equation here. And now we'll subtract it. We'll change the sign. Obviously, it was positive here already. We'll reverse the sign. We'll do it negative. Why? We have to cancel the x value, right? So if you want to put negative sign here, there is a rule in equation that you have to then put negative sign, like reverse the sign everywhere. Like if it was positive, do it negative. It is positive, do it negative, and obviously it's positive, do it negative. Now calculate the final answer. Calculate the final answer here. It will be like now 6x minus 6x will be 0. 3y minus 12y will be minus 9y is equal to 72 minus 37. 72, 37, basically 37 minus 72. It will be minus 35. Minus 35. Now on the both sides there are minus, just cancel them. Y is equal to 35 over 9. So y will be 3.8889 units. So what we have to do is to take the equations of critical constraint, just increase the value for which you have to calculate shadow price by 1 unit, like it was 36, I made 37. Then just take any variable, either x or y, and make its value same. How we have to make this? You take the bigger value of that variable, just divide it with the smaller value and take the answer that will be coming. You have to multiply that answer on both sides of the equation, like I have calculated it on the both sides of this equation. Now I come to know that 6x and 6x become same. Just subtract that so that the value of x becomes 0, and we are left with y. From there we can calculate the y number of units. Now we have calculated number of units of y. Now we can calculate the number of unit of x. We know the value of y. Just take this y and put it in. It's up to you. Take any equation. I'm taking equation 2. I'm taking equation 2 to calculate x. So to calculate x, equation I'm taking is 6x plus 12y is equal to 72. 6x we have to calculate, 12y you have already calculated, 3.8889 is equal to 72. So it will be into 1246.6. 6x is equal to 72 here. It was 72 here. I have just calculated it. It was 72. It will be 25.333. Now divided by 6, number of unit of x will appear to 4.222 units. If you see the old scenario, the number of units of x and y they have already calculated were 4. If you see this, it was 4 and it was 4. If you remember that, it was 4 and it was 4 for both x and y. But here you have calculated the number of units of x and y according to increase in 1 unit of cutting process. According to increase in 1 unit of cutting process. Now from here we have to calculate the contribution, maximum contribution that you can earn now. So for maximum contribution, always the equation will be given in the question. Always the equation will be given in the question. There was a equation, contribution equation here in the question. In the Kaplan, basically the contribution equation is given. Let me take that. Okay, so the contribution equation, actually it was given in the question upward in the book. I just forget to put here. So contribution is like 50x plus 40y. Actually, this is the contribution function, the objective function equation that was already given in the book. It is now complete question with the contribution as well. So we know that the contribution of x is 50 per unit. It will be given in the question, and contribution for y will be 40 per unit. So maximum contribution we know 50 for the x, multiply how many units now x is being made, there is being produced, 4.22 units, plus for y, the contribution per unit is 40. 40 multiply 3.8889. These are the y units. Let's calculate the complete contribution now. So 50 into 4.22 2 plus 40 into 3.8. So it will be 366.6 366.67. It means that when we increased the cutting process by 1 hour, our total contribution that we can earn in this scenario will be 366.67. 366.67. If you remember the old contribution that we have just read at the start, it was contribution 360. But when we increased 1 unit of cutting department, took it from 36 to 37, now contribution we are earning is 66.67. So we'll take the difference of both contribution. New contribution 366.67 minus old contribution 360. It will be $6.67 contribution, increase in contribution. And increase in contribution is actually the shadow price. So shadow price is actually the increase in contribution by increasing 1 unit of resource. So we have just increased 1 unit of resource, like cutting department we have increased by 1 unit, make it 37, and accordingly we have calculated the contribution. So the increase in that contribution is the shadow price. Now what you have to do, just calculate the shadow price for assembly hour. In case of, if you want to calculate shadow price of assembly, then this equation will remain same. 6x plus 3y will be 36, not 37 now. It will be 36. But for this 48, you will do 49. Just calculate it accordingly, do the simultaneous equation as I have done. Calculate the number of units of x and y, and then use this equation 50x plus 40y to calculate the contribution. Deduct it from the old contribution and it will be the shadow price. You are having 2 minutes to calculate it. Just calculate it. I'm waiting. Okay, so students, now you have calculated the shadow price of assembly. If you are confused in the question, you can text me on WhatsApp, right? Okay, there is one more question here. Let us see. Cut and stitch. Oh, cut and stitch. Make two types of suits using skilled tailors. Labor means basically skilled tailors are being used as a labor, and a delicate unique fabric material. Okay. Both the tailors and fabrics are in short supply. It means tailor T, and material fabric F. Tailor T and Fabric F are basically in short supply. Okay. So the accountant at CSS correctly produce a linear programming model to help decide optimum production mix. Okay. Variables are given. Let W is number of work suits produced, and let L is number of lounge suits produced. Actually, these are two types of products the company is making: work suits and lounge suits. So they have mentioned it like W and L. Now constraints, they have given you the constraints here. Constraints means obviously it can be critical or non-critical, but there are three constraints here. One is the tailor time. Yes, we have written here tailor time. Tailor time is a constant, and the equation is already given. 7W plus 5L is less than or equal to 3500 hours. Okay, this is the line T on diagram. If you see the line T, this is the line T. Okay. Then fabric 2W plus 2L is less than or equal to 1200 meters. This is a line F. Okay. Fabric has also the line F. Okay. Production of work suits W is less than or equal to 400, means number of units of W means work suits. Number of units of work suits, its demand, its production is also the constant. That is a line P on diagram. Okay, this line basically straight line. Straight line, why? As we have, if you remember, in the our question when we took y as the this line, y as the constant, so we made the straight line. But if x is the constant, we will make the straight line upward like this one, because when the y was constant we make like horizontally because it was a point on y. But if he says that x has a demand of like limited demand of 1200 or 1000 or 800, so we'll make a straight line like this if it's a demand. So same like that, they have made the line here with the mentioning p. Now, objective is to maximize the contribution subject to. This is the contribution line like 48W, and contribution of W is 48 and contribution of L is 40. Now what we have to do is to first calculate number of units normally using critical constant. First of all, we know that always optimum solution is used to calculate the maximum contribution, optimum point. So if you see the ISO contribution line that is given here, and he has already calculated the ISO contribution point as optimum point, that is B. Why B is the point? Because if you see the line far away from ISO contribution line, this is ISO contribution line, the line far away from ISO contribution line, if you see it, this line is actually used to calculate to see the optimum point, that the point that is far away from that line, right? So they have already mentioned that there are 2 points like intersecting line. One is this point, if you see, and one is this point. In the region, if you see, there are 2 points that are intersecting, point B and this point C. But obviously, they have mentioned you, they have already told you, you don't need to use the scale and just take the line upward and to see the which point is far away. They have already calculated, already told you in the question that B is, by using this dotted line, they have already told you that B is optimum point, means C is coming first. This C point is coming first, this C intersection is coming first, and after that this B intersection is coming. So B is the optimum point, and on this optimum point we will see that which two equations are coming, because we have to take those two equations that are coming on this intersection point, the point that is far away from iso contribution line. So if you see that this straight line is of P, so P will not be the critical constraint. It is the constant but not critical, because the it's not, this is a line that is like far away, that is not on the optimum point. Actually this is the line on which there is no optimum point. Optimum point is this one, on which there are two equations T and F. If you see, these the lines intersecting here are on the point B is T and F. So from here we come to know that Taylor and Fabric are the two equations that will be used to calculate maximum contribution, means it's on the optimum point, as we have done in the last question. So first we will calculate normal question we will do. We know one equation is 7W plus 5L is equal to 3500. 2W plus 2L is equal to 1200. From there, we will calculate the number of units of W and L. W and L. How? Again, same simultaneous equation. Where what we have to do, if you want to make the number of this W same, just take the bigger value. 7 divided by 2, it will be 3.5. Means with this equation, if we multiply 3.5, we can make the W value same. So 2 into 3.5 will be 7W plus 7L is equal to 3.5 into 1200 is equal to 4200. From here, this is the equation 1, equation 2. Just now what you have to do, again, same thing as we have done in the last question, 7W. But here, if you remember, if you see, we are not increasing the unit. We are not increasing the unit of like any of the constant. We are just calculating normal number of units, as we have done in the previous class, not in this class. We are not calculating the shadow price now. We are not calculating first the shadow price. We'll calculate afterwards. But first, obviously, we need to know about the units and contribution that is before that shadow price. Normal units, like in this question, if you see, they've already given you units, they've already given you the contribution, but here they haven't given anything. So you have to calculate first the units, number of units before calculating shadow price, general normal units and normal contribution. Then if we want to calculate shadow price, we'll calculate that afterwards by increasing 1 unit of the constant of which we have to calculate the shadow price. So just number of units I am calculating here for W and L in the normal scenario. If it's subtracted, we'll subtract it on all sides. It will be 0. It will be minus 2L is equal to minus 700. So L will be T50 units. So we come to know that for L, we'll make 350 units. So L we have calculated. Through this, we will calculate W as well, taking any of the equation. I'm taking equation 2, 7 to W plus 7L is equal to 4200. Just put the value of L to calculate the value of W. So it will be 350 into 7 to 2450 minus 4200 1750. So 7W is equal to 1750 and W will be 250. So we have calculated both of the products. We have calculated units. So from here we come to know that W will be made according to optimum production. W will be made 250 units and L will be made to 350 units. This is the normal units. And if we want to calculate the contribution, normal contribution, so contribution equation is given 48W plus 40L. So we can calculate that 48W plus 40L, 48W plus 40L. We can calculate that. So 48W, number of units of W is 250 plus 40, number of units of L is 350. So 48 into 250 plus 40 into 350. So contribution you will earn is 26,000 normally in the normal scenario, not in the shadow price. This is the normal contribution that you will earning on the optimum point, the maximum contribution. So whenever the question comes, first of all, you have to, if there is more than two constants, so it means there are two critical constant and one will be non-critical. Always in the question, there will be two critical constant because the intersection point will be there in the graph. So two equations will be critical constant, remaining will be non-critical. So from the equations, we come to know that there are three constants. So for three constants, they have mentioned that graph is given. When you go to the graph, we come to know that the production graph means this graph of W, that is a straight line, P graph, P line is outside basically P line is made straight and other two lines are also made. Then we have seen the ISO contribution line, and they have mentioned according to ISO contribution line, this point B is the optimum point. Using this point B, because it's the optimum point, we have taken both of the lines equation that are of Taylor times and fabric. The equations we have taken is from here. 7W plus 5L and 2W plus 2L, took that equation. Accordingly, we have calculated the number of units of L and number of units of W. From that, we just put the number of units in contribution equation to calculate maximum contribution the company can earn. This is the normal scenario if he's asking you to calculate L and W contribution. But now you know you have these two equations. Normally, you have these two equations. This, according to normal scenario, you have these two equations. So accordingly, if if they asked you to calculate shadow price of Taylor time. They can ask you for fabric as well, but just I am considering that if they ask you for Taylor's time. Now you have two equations. 7W plus 5L is for Taylor and 2W plus 2L is for fabric. So for shadow price, first what we have to do is to calculate is to do the increase the resource by 1 unit. So the equation will be now, if you want to calculate shadow price, 7W plus 5L is equal to 3501, because we have to increase by 1 unit the resource for which we have to calculate the shadow price. So 7W plus 5L is equal to 3501 and 2W plus 2L will be 1200. From here we will calculate. From here we will again do the equation, again do the complete calculation, and at last when we'll calculating the number of units, we'll multiply with the contribution 48 and 40. There will be some increase in contribution. For example, the contribution after that will be 26260 26,010. For example, just assuming. So obviously old contribution was 26,000, new contribution is 26,010. We'll say that shadow price will be 10. But this shadow price you have to calculate in assignment. This is your assignment. Just do the assignment, and whenever I give assignment, whenever in the lecture I give assignment, it doesn't mean that you don't do it. You have to do it. Submit it to me. I'll check it and I'll confirm you that whether you have done correctly or not. Till here, your complete calculation part is done for limiting factor. Only the last thing that we have to do is to discuss these assumptions of limiting factor. There are some assumptions of limiting factor. First of all, there is single quantifiable objective. Actually, limiting factor assumes, wait a minute. Okay, so I just forgot that we have already discussed this assumption in the last lecture. So the chapter is ended here. The chapter is ended here completely. We'll discuss the more practice. Obviously, more questions we'll do from the study hub in MCQ. Meet you guys in the practice. Till then, take care. Bye.